formation of a new world.
The images of the film you are watching are slowed down or accelerated, but are they screened forward or backward? Is it reversible? Try it. You won't notice the difference. The images in reverse appear to be extremely unlikely. However, in a universe that we are not completely familiar with, isn't anything possible?
Whoa, the cone nebula.
These images, whether forward or reverse, are fully compatible with the laws of physics, working in perfect symmetry with the idea of time reversal. However, there is a general principle.
Introducing entropy. It's how chaos and order are measured in the world.
The second law of classic thermodynamics states that entropy is constantly increasing. This principle is beautifully illustrated in the perpetual expansion and splendor of outer space.
So, are there more and more stars forming all the time?
Yes, and there are many more stars appearing than disappearing. In any spontaneous process, since the beginning of time, entropy of the universe is increasing, as well as the disorder. This is consistent with the theory of expansion of the universe. A wonderful example can be found in the formation of nebulas and galaxies. Ever increasing in volume since the Big Bang, the universe becomes more disordered, and therefore its entropy increases, necessarily tending towards a maximum. Under the law of entropy, organized systems left to themselves would, over time, become less and less stable and organized. In physics, entropy is the degree of disorder that exists in a system. The transition from a stable system to an unstable system corresponds to an increase in entropy. The instability of these stars and nebulas are directly related to entropy as well.
Here is a reflection of a nebula in Orion, thanks to entropy.
The second law of thermodynamics is generally regarded as one of the most important discoveries in physics. Albert Einstein considered this law as the first law of all sciences. And Boltzmann went as far as wanting to engrave the results of his research on his tombstone.
Did he? That's dedication.
The entropy of the white dwarf star in the middle of this nebula is what makes it shine so brightly.
By the way, a glass of white dwarf matter has a weight of more than 50 tons.
The law of entropy rejects outright many materialist arguments. If the universe was the result of an organized order, the law maintains that over time it would be offset by the universe itself. Conclusion: left to itself, the universe could not exist forever. Without any external intervention, the entropy of the universe will reach its maximum value, a critical time at which it will enter a state of eternal rest or thermal death, the clinical death of a large machine that has turned relentlessly oiled for billions of years. But will this mean the end of the world as we know it, or just a miraculous drop of order in a sea of chaos?
Interstellar eggs in the Eagle Nebula looks like a baby nursery for stars.
The assertion that the cosmic order is the result of an external intervention is not altogether false. Just following the Big Bang, the great explosion which brought about the universe as we know it, the cosmos found itself in a creative disorder, the exact situation in which the entropy would have been maximized. Located on the edge of our Milky Way, the red supergiant star Monocerotis is surrounded by dusty cloud structures known as light echoes, which illuminate the cosmic dust. Monocerotis is very unusual in that it did not expel its outer layers, instead growing enormously in size. Monocerotis exhibits a phenomena similar to that of a nova, a normal star that dumps hydrogen onto a compact white dwarf companion star. The hydrogen piles up until it spontaneously explodes by nuclear fusion, like a hydrogen bomb, exposing a searing stellar core. The famous Cat's Eye Nebula represents a phase of stellar evolution that the Sun should experience several billion years from now. A fast wind emanating from the hot core, pushing it outward, shedding material at a speed of about 4 million miles per hour, creating the graceful filamentary structures seen with optical telescopes. Its central star is surrounded by a cloud of multi-million degree gas. In the case of the Cat's Eye, the star itself is expected to collapse to become a white dwarf star in a few million years. A pulsar is a pulsating neutron star emitting beams of radiation that sweep through the Earth's line of sight. Like a black hole, it is an endpoint to stellar evolution. The pulses of high-energy radiation we see from a pulsar are due to a misalignment of the neutron star's rotation axis and its magnetic axis. The cosmic order that reigns in the universe is the most profound evidence of the existence of a higher consciousness. Nobel laureate physicist Max Planck explains that there is evidence of the existence of an unseen intelligent order within the universe, an order outside of human comprehension, stranger than we can possibly imagine, in which our planet, and even our galaxy, plays an insignificant role. Others go even further by explaining the triumph of this marvelous balance and harmony. Everywhere we look in the visible universe, from faraway galaxies to the microscopic depth of the atom, we find this order.
Are there butterflies in outer space?
The Butterfly Nebula is a bright and conspicuous planetary nebula located on the celestial equator in the Monoceros constellation. When one of the two stars evolved into a red giant, it engulfed its companion star, which stripped away a ring of material from the larger star's atmosphere. When the red giant's core was exposed, a fast stellar wind inflated two bubbles from either side of the ring. Strange situation. The order has a natural tendency to disappear. But where does it go? And where did it come from? The universe is like a clock that slowly loses track of time. But how was time initiated in the first place? Einstein refers to this as an unexpected event, going as far to say that it is a miracle, reinforced more and more by the development of our consciousness. Some nebulas may form as planetary nebulae. This is the final stage of a low-mass star's life, like the Earth's sun. In keeping with the principle of cause and effect, we assume that the world follows certain laws, but only to the extent that we human beings intervene, using our conscious ability to organize, to make sense out of the chaos that surrounds us. Yet instead of that, we find ourselves in an objective world in which there is a high degree of order we do not expect. A miracle, which is further reinforced by the development of our knowledge and consciousness. The order, which reigns supreme in our world of creative chaos, can be a major hindrance to those who see the universe as a mere mass of matter left to its own devices. Hubble Space Telescope observations reveal remarkable structures such as knots, jets, and sinewy arc-like features. Modern studies reveal several mysteries. The intricacy of the structure may be caused in part by material ejected from a binary central star. But as yet, there is no direct evidence that the central star has a companion. Astronomers predict that billions of years from now, the larger galaxy will eventually incorporate the smaller galaxy. The Cartwheel Galaxy was created by a near head-on collision with a smaller galaxy about 200 million years ago. A star's tremendous energy comes from a process known as nuclear fusion. This process begins when the temperature of the core of the developing star reaches about 1 million degrees. When the temperature and pressure in the protostar's core become high enough, nuclear fusion begins. Nuclear fusion is a joining of two atomic nuclei to produce a larger nucleus. A star develops from a giant, slowly rotating cloud that consists almost entirely of the chemical elements hydrogen and helium. The cloud also contains atoms of other elements, as well as microscopic particles of dust. Planetary nebulae are ball-like clouds of dust and gases that surround certain stars. They form when a star begins to collapse and throw off the outer layers of its atmosphere. When viewed through a small telescope, this type of nebula appears to have a flat, rounded surface like that of a planet.
The term nebula comes from the Latin word for cloud.
A nebula is a cloud of dust particles and gases in space. Early astronomers also used the term for distant galaxies outside the Earth's galaxy, the Milky Way. Such galaxies, called extragalactic nebulae, looked like hazy patches of light among the stars. But modern telescopes show that extragalactic nebulae are actually systems of stars similar to the Milky Way. Today, most astronomers use the term nebulae only for the clouds of dust and gases in the Milky Way and other galaxies. Some nebulae contain enough dust and gases to form as many as 100,000 stars the size of the Sun. The intense ultraviolet light from the star energizes the gas atoms of the nebula and enables the mass to emit light. Gravity causes a portion of a nebula's dust and gases to contract into a much smaller, denser mass. Pressure and temperature build up within the mass of dust and gases as contraction continues for millions of years. In time, the mass becomes hot enough to shine, forming a new star. Many nebulae form from the gravitational collapse of gas in the interstellar medium. As the material collapses under its own weight, massive stars may form in the center, and their ultraviolet radiation ionizes the surrounding gas, creating plasma, making it visible at optical wavelengths. Most nebulae are extended and contain no well-defined boundaries. Although the nebulae appear different at optical wavelengths, they all appear to be bright sources of emission at infrared wavelengths. This emission comes primarily from the dust within the nebula. Radiation from hot young stars has slowly eroded the nebula over millions of years. Ultraviolet light heats the edges of the dark cloud, releasing gas into the relatively empty region of surrounding space. There, additional ultraviolet radiation causes the hydrogen gas to glow, which produces the red halo of light. Background stars can be seen peeking through the evaporating tendrils of gas, while the turbulent gases are pockmarked with stars reddened by dust. Over time, only the densest regions will be left. It is inside these regions where stars and planets may form.
Because like they say, nature doesn't like a vacuum.
Captured by the Hubble Space Telescope, the Triangle Nebula is one of the largest known seething cauldrons of starbirth to be seen in a nearby galaxy. In many ways similar to the familiar starbirth regions of our Milky Way galaxy, such as the Orion Nebula, this festively colorful nebula is vastly larger in extent and contains many more recently formed stars. The universal force of gravity causes matter to gather together in big clusters and spin. Gas and dust collect into large balls, forming galaxies. These gas balls slowly flatten out into a disk shape, spreading apart. Tight gas balls materialize in the galaxies, bringing forth new stars. A huge star dies dramatically. As fuel disappears, the star compresses. The center of the star changes into iron. A supernova begins to explode. Only a neutron star remains. In one galaxy, somewhere in the middle of all this confusion, a star is born, spewing hot gases into the surrounding area. Gravity forces 2 light years of dust and gas clouds to collapse. Being compressed, nuclear fusion heats up the star to over 15 million degrees. The excess gas builds new planets which are burning hot. Over the next million years, the planets slowly cool. Planets hit by debris break up into smaller chunks. These chunks, or asteroids, continue to orbit. Within the galaxy, stars convert hydrogen to helium to produce light and other radiation. As time progresses, the heavier helium sinks to the center of the star, with a shell of hydrogen around the helium center core. The hydrogen is depleted, so it no longer generates enough energy and pressure to support the outer layers of the star. As a star collapses, the pressure and temperature rise until it is high enough for helium to fuse into carbon, where helium burning begins. To radiate the energy produced by the helium burning, the star expands into a red giant. Nothing can escape. A star cluster, or star cloud, is a tightly grouped swarm of stars held together by gravity. Stars as cluster members will continue to move in broadly the same direction through space. They are then known as a stellar association. Until recently, star clusters were the cause of a great mystery in astronomy, as theories of stellar evolution gave ages for the oldest members of globular clusters that were greater than the estimated age of the universe. Stellar clusters are important in many areas of astronomy. Clusters are also a crucial step in determining the distance scale of the universe. The Whirlpool Galaxy is an interacting, grand design spiral galaxy and is one of the most famous spiral galaxies in the sky. The galaxy is about 30 million light-years away, 15 times farther out than the famous Andromeda galaxy. Its substantial size and brightness mean the Whirlpool Galaxy is probably bigger and more luminous than our Milky Way galaxy or Andromeda. Here, the inescapable force of gravity compresses wispy clouds of gas sprinkled with dust and spanning many light years into thousands of stars over millions of years. The gas clouds themselves are highly structured with dust lanes, intricate as lace, threading through them. Spiral arms are busy stellar nurseries. They appear bright because of the copious energy generated by short-lived heavy stars that soon, astronomically speaking, end up in a supernova. Clearly visible are the compressed, dusty gas clouds in the inner edge of the spiral arms, the prominent pink starbirth regions, and the bright blue clusters of young, hot stars along the outer parts of the spiral arms.
Empty space is not so empty after all.
Astronomers have detected clouds of hydrogen gas in what were thought to be giant voids hundreds of light years across between clusters of galaxies. Stars form when extremely cold clouds of hydrogen collapse under their own gravity until they become dense enough to ignite nuclear fusion. Over billions of years, this leads the formation of the heavier elements that make up planets, people, and other matter. Each galaxy should contain gas masses equivalent to several billion stars, as in the Milky Way. Scientists estimate that there are more than 100 billion galaxies scattered throughout the visible universe. Astronomers have photographed millions of galaxies through telescopes. The most distant galaxies ever photographed are as far as 10 billion to 13 billion light years away. A light year is the distance that light travels in a vacuum in a year, about 10 trillion kilometers. Galaxies range in diameter from a few thousand to 500,000 light years. Small galaxies have fewer than 1 billion stars, while large galaxies have more than 1 trillion. All galaxies emit energy as waves of visible light and other kinds of electromagnetic radiation. The energy emitted by galaxies comes from various sources. Much of it is due to the heat of the stars and of clouds of dust, gas, and nebulae. Scientists have proposed two main theories for the origin of galaxies: the bottom-up theories and the top-down theories. The starting point for both kinds of theories is the Big Bang, the explosion with which the universe began 10 to 20 billion years ago. Shortly after the Big Bang, masses of gas began to gather together or collapse. Gravity then slowly compressed these masses into galaxies. The two kinds of theories differ concerning how the galaxies evolved. Bottom-up theories state that much smaller objects, such as globular clusters, formed first. These objects then merged to form galaxies. According to top-down theories, large objects, such as galaxies and clusters of galaxies, formed first. The smaller groups of stars then formed within them. But all Big Bang theories of galaxy formation agree that no new galaxies, or very few, have formed since the earliest times. The differences in galactic strength arise from tiny increases in the density of matter in the universe shortly after the Big Bang. The small regions of increased density had a stronger gravitational force than the surrounding matter. Clumps of matter therefore formed in these regions, and the clumps eventually collapsed into galaxies. Most astronomical observations made to date support Big Bang theories. According to these theories, the universe is still expanding. Two kinds of observations strongly support the idea of an expanding universe. These observations indicate that all galaxies are moving away from one another, and that the galaxies farthest from the Milky Way are moving away most rapidly. This relationship between speed and distance is known as the Hubble law of recession. The law was named after American astronomer Edwin Hubble. Scientists estimate the distance to galaxies by measuring the galaxy's overall brightness, or the brightness of certain kinds of objects within them. Stars are created within galaxies from a reserve of cold gas that forms into giant molecular clouds. Some galaxies have been observed to form stars at an exceptional rate, known as a starburst. Starburst galaxies are characterized by dusty concentrations of gas and the appearance of newly formed stars, including massive stars that ionize the surrounding cloud regions. Starburst activity usually lasts for only about 10 million years, a relatively brief period in the history of a galaxy. The spectacular dark band of absorbing dust in front of this galaxy's bright nucleus gives rise to its nickname, Evil Eye Galaxy. A merged star system with an unusual appearance, as well as bizarre internal motions. The Sombrero Galaxy's most striking feature is the dust lane that crosses in front, a symmetric ring that encloses the bulge of the galaxy. Most of the cold atomic hydrogen gas and dust lies within this ring. The ring might also contain most of the Sombrero Galaxy's cold molecular gas and is the primary site of star formation. Active formation of new stars is occurring in the shear region where the oppositely rotating gases collide, are compressed, and contract. Particularly noticeable are the rose-colored clouds of glowing hydrogen gas that fluoresce when exposed to ultraviolet light from newly formed stars. The current era of star formation is expected to continue for up to 100 billion years. And then, the stellar age will wind down after about 10 trillion to 100 trillion years, as the smallest, longest-lived stars in our astrosphere, tiny red dwarfs, begin to fade. At the end of the stellar age, galaxies will be composed of compact objects, brown dwarfs, white dwarfs that are cooling or cold, known as black dwarfs, neutron stars, and black holes. Eventually, as a result of gravitational relaxation, all stars will either fall into central supermassive black holes or be flung into intergalactic space as a result of collisions.
Supermassive black holes don't look black because there are billions and billions of stars falling in. It's full of light.
Recently adopted in astronomy, dark matter is the mysterious explanation for what holds the galaxies together. Dark energy is an intriguing hypothetical form of energy affecting the expansion of the universe. The universe appears to not just be expanding, but accelerating at an ever faster pace. Dark energy currently accounts for 74% of the total mass energy of the universe. The exact nature of this dark energy is a matter of speculation.
There's more to these galaxies than our eyes can see.
Since the Hubble Space Telescope was launched in 1990, there have been many observations of what are believed to be black holes, a subject in theoretical physics long before there were any observations by astronomers. Most of what we believe we know about black holes has come from abstract theoretical models in general relativity. Einstein's general theory of relativity gave physicists a mathematical language for describing the gravitational force in a manner consistent with the constant speed of light. The most distant galaxies yet observed appear as faint patches of light. The brighter swirls are galaxies somewhat closer to Earth, and the bright colored objects are stars in our own galaxy. The telescope photographed this tiny portion of the sky, calling it the Hubble Ultra Deep Field. If you look at the stars on a clear night, you will notice that they seem to twinkle and that they differ greatly in brightness. Twinkling of stars is caused by movements in the Earth's atmosphere. Starlight enters the atmosphere as straight rays, and air movements constantly change the path of the light. Imagination is more important than knowledge, for knowledge is limited, whereas imagination embraces the entire world, stimulating progress, giving birth to evolution.
Albert Einstein.